Welcome everyone. So in this video I will be explaining the solution to the problem GCD 2.1, both easy and hard versions. There is not much difference in easy and hard version, so we will look into both, right? So the problem statement is pretty much straightforward. It is that we are given a matrix A of size n into m, and such that the GCD of we have to construct a matrix of size n into m such that the GCD of every row and column is 1 and the sum of the element is minimized, and this is only in the hard version. So in this problem, if you see in the hard version of the problem, the only difference in the easy and the hard version is that in this particular thing we have to minimize the number of we have to minimize the sum of all the elements of the matrix, right? And in the easy version we don't have this boundation, the minimization of sum, right? And the element range should be starting with the 2 up to 10 raised to the power 9, right? And there can be multiple answer possible. We can print any of them, right? So this is a pretty much simple problem statement. We just have to construct a matrix such that every row and column has GCD 1, right? And for the guys who don't know what is GCD, it represents the greatest common divisor. So let's say if you pick 6 and if you pick 10, so what is the greatest number which can divide both of them? That will be the GCD of 6 and 10. So in the case of 6 and 10, 2 is the greatest number which can divide both 6 and 10, right? So the simple definition of GCD is the greatest number that can completely divide those two numbers which we are getting the GCD for, right? So input is very much simple. We have t number of test cases, and every test case we are provided with n and m, and in the output we have to give this metric, right? So yeah, now we will solve this problem. And yeah, now start with this, that our bound is to make every rows and columns GCD to 1, right? Now think of it. Let's say if you pick a prime number, and you know the property of prime number is that it can only be divisible by 1 and itself. And you know 1 is not the case here, because in the array elements bound we are given that array element should minimum be 2. Now array element cannot be 1. I mean the metric element cannot be 1, right? So think of it, the GCD represent basically, let's say if you pick a prime number, and prime number can only be divisible by himself and the 1, right? So let's say if I have prime number 17, right? And if there is any other number, let's say whatever the number is 20 or whatever you pick, the GCD of this, the GCD of prime number and any other number will always be 1, right? And also I'm considering this any other number is greater than 1, and even if this is 1, then GCD will always be 1, right? And this any other number should be other than p, which is the prime number, right? Now just think of it, what is the minimum prime number which you can think of, which is of course 2. So let's take one prime number as 2, and what is the other just more than it other minimum prime number, which is, let's say I pick 3. So 2 and 3 are the most smallest prime number we have, and you know the GCD of 2 and 3 will be 1, right? Now just imagine a row and column with me. Let's say if you want to make a row and column, you make it like this: 2 2 2 2, and the GCD up till here will be 2, and as soon as there is 1 3, the GCD up to all these things will be 1, right? So if you want to make the minimum sum, now the GCD will be 1, right? GCD, right? So if you want to make minimum sum of metric, then think of it like this. Firstly make all elements of matrix 2, matrix 2 2, make all elements equals to 2, make all element of matrix equals to 2, right? Now you just have to pick rows and column. You just have to make 3 on some particular cases, such that, because let's say if you take this particular example, just you can consider this as a row or column, whatever. Even if there are a lot of 2, only 1 3 will do the work for you, right? You only need 1 3 to do the work for you. Let's say if my n is 4 and if my m is 4, let's say if your n and m is equal, so the places of the matrix is like this: 2 2 2 2 2 2 2 2 2 2 2 2. Is it fine? Yeah, that seems okay to me. Yeah, so this is your matrix. Now what you can do, you can just make a 3 here and make a 3 here and make a 3 here, and there will be one more row which is 2 2 2 2 2, and you make a 3 here, right? So just consider this thing: in every row and column you have at least 1 3, right? You have 1 3 here, you have 1 3 here, and you have 1 3 here, and you have 1 3 here. And simply if you consider in this way, you have 1 3 here, and in this you have 1 3 here, you have 1 3 here, and you have 1 3 here. So you can put all the 3's diagonally. Right? Now what if n is unequals to m? So what if it is not a square matrix? So consider this: let's say if you have n equals to 2 and m equals to 3, and you the first thing is to make all elements of the matrix equals to 2. So this is what I'm doing. So I'm making this matrix and I'm making all elements equals to 2, so such that I can do it like this: 2 2, and then there is again 2 2, and then there is 2 2, right? So I have this matrix. Now I will put the 3 diagonally again. So now I will put 3 here and I will put 3 here. And now as soon as your diagonal ends, you can put it whatever the longer side is. So in this case the longer side is the vertical one, so I can put my 3 here. And now what if there is a different case? What if there is a case of 2 2 2? So that is 2 2 2. You again put diagonally. I start by putting it here, then I will put it here, and now whatever the longer side is, so here the longer side is the horizontal one, then I will put my 3 here. So in this way it will cover all the things, right? It will cover up to here, 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 and also in this way, right? So this is the simple constructive approach. And now using this code, you can also do the easy version and the hard version. I told you the hard version because the difficulty in both of them is not much, right? So now I will show the code to you, and I have done a very much simpler implementation. So you can take a look here. So I have taken the input of n and m, and then I have made a vector of vector, so which is a 2D array, right? And this is how you make a vector of vector, and this is how you initialize. There are n number of rows and m number of columns in each row, right? And you initialize and whatever the number you pass here, this is the thing which you initialize with. So I have initialized my complete matrix by 2, right? And now I have to find what is the longer side is. So longer side is, I can find it by n comma m, right? So z, let's say if I pick z is the length of the longer side, right? And I start my I start putting 3's from the upper left corner. You can see in the notes we always start putting from the upper left corner, and the coordinate of this is 0, 0, right? So I have initialized my elements of a and b from the 0, 0, and now I'm just iterating through the longer side, right? And I'm putting my 3 diagonally, and I'm incrementing my a by 1 and my b by 1. So you can see you can see here, so I will increment. Let's say if you pick this case, there is 0 comma 0, then this is 1 comma 1, now this is 2 comma 2, and this is 3 comma 3, right? And if you come here, this is 0 comma 0, this is 1 comma 1, and now this will increment if the increment is possible, such that we can apply it using this operation. So if the increment is possible, it will do a plus 1, and if the incrementing goes out of the bound, it will remain up to this, right? Because we always take the minimum corresponding to the side, right? So this is a very much simpler implementation, and these type of implementation problem helps you to connect your thoughts with the code, right? Because in the CP, the most important thing is whatever you are thinking, you should be able to code it, right? And this is how you simply output your metric. So it's a very simple code, and I will put the this solution in the description. And also I would like ask you guys to just look at my boilerplate video. It's a really good boilerplate. I have provided really amazing feature there, and so the boilerplate is this one only. There are a lot of features, there are a lot of things which is very helpful for you guys. You can take a look at that, and thank you.